In this video, I want to have a look at how we can describe the shape of a data set. So when we're looking at stem and leaf plots or histograms or dot plots, we can see the overall pattern and shape that the data forms. So data can be symmetrical. So if we draw the general curve on, it looks like this. So it's the same on both sides. It can be negatively skewed, which looks something more like this one, or it can be positively skewed that looks like this. So when we're talking about skewness, we're always going to look for where the tail of the data is. So for example, in this one, the tail comes down this way, this long extra bit down here, and that's going towards the smaller numbers, so that's negatively skewed. Whereas the tail in this one comes down this side, so because that's going towards the bigger numbers, that's going to be positively skewed. Now the other thing we can also say is that the distribution is bimodal, meaning that it has two modes or two peaks. So let's have a look at some examples. So it says for each statistical distribution, describe the shape and then identify any outliers and clusters. So for this one, if we draw the general shape in of that curve, if my pen works, you can see that it's got a long tail coming down towards this one. So because it's got its tail coming down towards the smaller numbers, that's going to be negatively skewed. So that's part one, identify the shape. Part two asks us to identify any outliers and clusters. So outliers are the ones that are scores that are down on their own, so that would be a 10. And the clusters are where our data is bunched together. So again, it's a little bit ambiguous. You could kind of say that the cluster is from 13 to 17, or we can just say where the main bulk of the data is. So we could say between 15 and 17. All right, in our next one, we've got a stem and leaf plot. We can draw the general shape of that on, but to see whether it's positively or negatively skewed, we're actually going to turn this whole thing sideways. So when we turn it sideways like that, you can see that it's got this tail coming towards the higher numbers. So that means it's going to be positively skewed. And part two asks us to look at outliers and clusters. So there's no obvious outliers when you first look at this because there's no big gaps in our data display. But when we actually look at the numbers, our highest number is a 98 and the next number down is an 84. So that means there's a gap of 14 between those two scores. So 98 does look like an outlier to me. And the clusters, again, I'm going to say where the bulk of the data is. So I'm going to say in the 40s and the 50s. All right, we've got two more data displays to have a look at. So in this one, again, if we draw the general shape on, you can see the bulk of it's up here and then it trails off towards the end. So because it's trailing off towards the higher numbers, that's going to be positively skewed. For part two, we're looking for outliers. So your outlier in this one would be this 15 that's up here on its own. And the clusters, the cluster, again, I'm going to go for sort of where the bulk of it is, which is this peak up here. So I'm going to say about 3 to 5. And our last one over here, again, let's draw in the shape of our data. And if we turn it sideways, you can kind of see that it's looking pretty symmetrical. But if you look at the heights of the columns, each one is the same height as its opposite there. So even though my curve isn't accurate and it doesn't look perfectly symmetrical, if you look at the heights of all the columns, you can see that it is symmetrical. So for part one there, I'm going to write symmetrical. And then we're also asked to look for outliers and clusters. So our outliers, it doesn't really look like there are any to me, so no outliers. And the clusters, I'm going to say in the 130s because that's my tallest one there. So that's having a look at how we can describe the shape of a data set.